Another important force that we deal with a lot is friction. Okay, and so to understand friction, and we'll go more into detail in some of the later chapters, but it's still going to be necessary passing this first quiz. And I'll draw this a little bit bigger here. So the basic idea behind friction. Let's look at an example of a man pushing a box. Okay. So if we look at the box initially, and let's say we haven't started pushing on it yet, okay, then in the first instance, okay, if we are to write, so there's two different types of friction. The first is static friction, and the second is kinetic friction. So we're going to look at static friction first. So in the case of static friction, okay, initially, if the box is just sitting at rest, then there's no force due to friction, right? We've seen already that the only forces acting on the box are the force of gravity, which is acting down, and the normal force, which is acting up. Okay, but now let's say we have a person, and let's say this is a really big box. So the person starts to push on the box. Okay. So when he does this, he starts to apply a force F. Okay. So initially, let's say he's applying some small force F1. So then in this case, there's a frictional force that opposes it, that's equal in magnitude and opposite in direction. And so this is a force of static friction. And so this is equal to minus F1, acting at the bottom there. But the person starts to push a little bit harder. So now he's applying a force, F2. Well, if that's still not enough to move the box, as you can imagine, you're trying to push a very heavy box, you can push a little bit harder and still maybe not move it. So in that situation, now it becomes the force of friction is minus F2. Okay, and then let's say he pushes just a little bit more, just to the point where the box just barely doesn't start to move. So once again, we'll still have a force of static friction, and it's equal to minus F3. Okay. But if you've ever actually done this, if you've ever been moving like a refrigerator, or a really heavy object, you'll notice that if you finally get over that that little bit, and you finally get to, it finally starts to move, all of a sudden it becomes much easier to push it, right? It was much harder to overcome, to initially get it moving, than it was to keep it going. And that's because the other frictional force, the force of kinetic friction, is always less than the largest static friction that you can have. So what that means is once you've applied that, then if you're still applying, the same force F3, you're going to have a kinetic force, which is just a friction, in the opposite direction. And this is going to be, so this is going to be the force of kinetic friction, and this is going to be less than the force that you're applying, because this friction we only have when something's moving. And again, we're going to talk a little bit more about this in the later chapters, and what the difference between static friction and kinetic friction is. The important thing is just to remember that it always opposes motion. Okay, so for this example, we were applying a force to the right, and so the friction was going to the left. If instead we had been, we had a box and we're pushing it to the left, then we would have had, a frictional force, either static or kinetic, going to the right.